Hello everyone, it's time to learn macroeconomics. Today we are moving to a new topic which is unemployment. For part 1 we are going to learn the unemployment dynamics, and then we are going to learn how to calculate the natural rate of unemployment. Of course we are going to learn its definition as well. And then we are going to use our understanding to calculate the underlying job finding rate and job separation rate in the economy, which are the two important rates to understand unemployment. And then we are going to study the effect of the change of job finding rate at the end. Now we're going to learn unemployment dynamics. To understand unemployment dynamics, we have to know there are three different statuses that a potential worker can have. Either he can be out of labor force, which means that he cannot or do not look for jobs. Or he is interested in working, but he cannot get a job. In this case, we say that he is unemployed. Or he actually get hired and is working, then he is employed. So these are the three statuses that a potential worker can have. And for those two on the right, we will say that this person is in the labor force. And for any person, he can switch between these two statuses, these three statuses freely. He can be either not interested in looking for a job and he's decided to look for a job but still cannot get a job. Then he switches his status from out of labor force to being unemployed. Or he finally get a job and get employed in some company, then he switches his status again to be employed. And then he can get fired and still looking for a job, then he is unemployed. Or he decided not to work at all, then he will be out of labor force. And in our previous model, equilibrium model, we can explain why some people would be employed and why some people is out of labor force. In the equilibrium model, under the equilibrium wage rate, if a person wants to work, he definitely can get a job. And if he decides not to work under the unemployment wage rate, then he is out of labor force. We won't call him being unemployed. Therefore, the previous model missed the picture to explain why for people who are interested in working, some of them can be unemployed. So we want to build a model to focus on the switching of status between employment and unemployment. Now we focus on those who are in the labor force, and therefore we only look at these two statuses. For a person who is unemployed, he can switch his status to become employed. In this case, we say that he finds a job. Of course, the person who is employed can get unemployed. In this case, we say that he faces job separation. Now we move on to the dynamic calculation of unemployment and employment. We look at the dynamics between yesterday and today. We use 0 to represent yesterday and 1 to represent today. For the unemployment pool, the total population of unemployed worker is U0, and the total number of employed worker, we use the notation L0. So from yesterday to today, there will be some unemployed people, they are going to switch their status to become employed. And these people who find a job, we assume that the portion of the population in U0 that will find a job, this probability is phi1, which means that there will be 1 minus phi1 population will stay put in the unemployment status. So the group from the unemployment pool will be separated into two groups. And phi U group would move their status to the employment group. And the remaining 1 minus phi times U would stay put in the unemployment group. Now we switch to the employment. For the employment group, some of them will switch their status to become job separated. They will become unemployed. We assume the portion of people who will be unemployed would be sigma 1. Therefore, 1 minus sigma 1 of them will stay put in the employment status. So the employment group from day 0 yesterday will be separated into two parts. The sigma L part would change his statuses to become unemployment. And the remaining 1 minus sigma times L group will stay put in the same status as before, that is employment. So together we know that Today's new unemployment population, U1, will be simply the sum of these two that we saw, which is the 1 minus 5 times U, those who did not change their status from yesterday, plus those employment people who got laid off and changed their status to unemployment today, sigma L. And then this will give us the unemployment evolution equation. And then we can move on to the employment evolution equation. For today's employment L1, it will be simply the sum of these two. And therefore, we have the employment evolution L1 is equal to those L0 that did not change their status plus those U0 that had changed their status. Now we are going to use these two evolution equation to calculate the dynamics of employment and unemployment. We use the number in this example. We have on day 0, there are 135 million on employment and 15 million unemployment. And we assume that the job separation rate, which is the probability of job separation, sigma, is 3%, and the job finding rate is 50%. And therefore, we first calculating the employment on day 1, which will come from those from day 0 that stay put in employment, which means that 1 minus 3% of those people will stay put in employment. So we have 1 minus 3% times 135. However, we will still have some people joining the employment group from the unemployment group. The portion of these people from the unemployment group would be simply the job finding rate, 50%, times the 15 million of unemployed worker, which would give us the number 138.45 million worker that will be in employment group. And now we switch to the unemployment group for day 1. Then we use the following employment evolution equation. First, among those 15 million workers unemployed on day 0, and 1 minus 50% of them will stay put. And the other part of the unemployment people come from the employment people. We know that 3% of those employment people will become unemployed. That's why we would add 3% times 135. This would give us the unemployment population on day 1 to be 11.55 million. Following the same reason, we can continue to calculate the employment population for day 2. There will be 1 minus 3% of those employment workers who stay put, plus 50% times 11.55 of those who change the status from unemployment to employment. This would give us the number 140 million workers stay under employment. And then for unemployment, we will have 1 minus 50% of those, 11.55, will stay put in unemployment. And we will have some 3% of those 138.45 employed workers become job separated and become unemployed. This would give us a total number of unemployment to be 9.9 million. If we continue the calculations forward, then we are going to track the dynamic of employment and unemployment. For employment, which is the gray dot line, which will look like this line, and the unemployment dynamic will look like this red line if we continue our calculation. Now we are going to learn how to calculate natural rate of unemployment. In our previous employment and unemployment dynamics, you can see that when the horizon goes for infinity, then their levels seem to stay constant. So if the job separation rate sigma and job finding rate phi represent the long run average of these two rates in the economy, then this constant level will represent the natural rate of employment and unemployment. Now we want to learn how to calculate it. So to understand what would be that constant level, we have to understand under what condition will the status quo stay constant. we use unemployment pool as an example. If the unemployment pool number is U and the long run job finding rate phi, then we know that in each period, phi U of them would jump out of the unemployment pool. And if the long run job separation rate sigma is a represented rate, and then we know that in each period, sigma times L of those employed worker will change their status and joining the unemployed group. So in order for the unemployment number to stay constant, then the number of people who joining the group should be equal to the number of people who jump out of the group. So we got this equality. When this equality holds, then the total unemployment will stay constant. Now we are going to use this equation to answer the question, what would be that steady state employment level? Assume that in the economy, the long-term average of job separation and finding rate, sigma, is equal to 3% and phi is equal to 50%. So with this equality, we know that 3% of L would be equal to 50% of U when we are in the long-term employment steady state. So given this equality, we will know that the long-term steady level of employment L over long-term steady level of employment will be equal to 50 over 3, which means that in the long run, when the economy stays constant, then whenever there are 50 employed workers, we will see 3 unemployed workers. Now, if we want to calculate these natural employment rate, it will be simply the total employment, 50, divided by the total labor force. In this case, would be 53. So the natural employment rate would be 94.34%. And the natural unemployment rate will be simply the total unemployed worker, 3, over total labor force, 53. Then we will get the natural unemployment rate to be 5.66%. So when we obtain these two rates, then we can calculate what would be the total number of employment and unemployment in the long run. In our previous numerical example, our total labor force is equal to 150 million workers. So which means that the natural employment level would be 150 million times 94.34%, which means that in the long run, in this economy, there will be 141.51 million workers stay employed. And to calculate the natural unemployment, then it will be 150 million times 5.66%, which is equal to 8.49 million of unemployed workers in the long run. So back to the dynamic figure that we saw. So the one on the top, the long run level of the employment level will be 141.51. That is the number we calculated earlier. And the long run unemployment level would be 8.49. That is what we calculated in the previous slide. Now we are going to compute job finding and separation rates from data. So we use the evolution equation that we obtained earlier. In these equations, then we can always obtain the unemployment and employment data from government website. So once you obtain these numbers, you can use these two equations to compute the underlying job finding rate phi and the job separation rate sigma. Now we plot unemployment rate fluctuation with job separation rate fluctuation. In this figure, there's something weird. From the figure, we know that whenever job separation rate go down, it should be difficult for people to get separated from their job. They should be able to stay employed longer. But however, we see the unemployment rate somehow goes up. And when job separation rate goes up, it means that people can get separated from their job much easier than before. However, unemployment rate goes down. This is weird. So then we turn to job finding rate. For job finding rate, we find that when the job finding rate goes down, means that it's very difficult for people to get a job now. Then the unemployment rate goes up. And then when job finding rate goes up, then it's easier for people to find a job, then unemployment rate goes down. This is much more intuitive and make much more sense. So based on these two figures, actually economists realize that in order to understand the unemployment fluctuation, the key answer actually lies on the fluctuation of job finding rate instead of on job separation rate. So in the future, we are going to construct a model focusing on the fluctuation of job finding rate in order to understand unemployment rate. From the data observation, we know that job finding rate actually is the key element that moves unemployment rates around. So in the following topic, we are going to see how the change of job finding rate affect the unemployment dynamics. So we start from the steady state unemployment and employment rate. The employment and unemployment rates are the natural rates that we computed earlier. They are 141.51 for the natural employment population, and the natural unemployment population would be 8.49 million. That is under the rates of job separation to be 3% and the rate of job finding to be 50%. So then we start to imagine a scenario that on day one, the job finding rate dropped. It became more difficult to find a job. It dropped from 50 all the way to 40. And then maybe economy started to recover, then the job finding rate goes up to 45. And we assume it stays there forever. And we are going to see how unemployment is going to move around with the change of job finding rate to see whether the pattern is consistent with data observation. So if period 1 job finding rate dropped to 40%, which for the employment part there will be 1 minus 3% times 141.51 will stay put to be employed. And however, because of the job finding rate become lower, so which means that the unemployment people, only 40% of them will be able to switch status to become employed. And when we sum them together, we get the new employment number to be 140.66 millions of workers to be employed on day one. For unemployment, then among the 8.49 million unemployed workers, then there would be 1 minus 40% of them, which means 60% of them will not find a job yet. They will stay put in unemployment. And other than that, 3% of 141.51 employed workers would get separated from their job. So when we sum them together, we have 9.34 million unemployed workers. Then we move on to period 2. Period 2 employed workers, some of them will got job separated. So only 1 minus 3% of them will not be separated. And however, among those unemployed workers, now there will be 45% of them will be able to find a job and switch status to join the employment group. This would give us a number of employment to be 140.64. And then for unemployment, 9.34 unemployed workers, some of them will still stay put, which means they cannot find a job. The percentage of people who cannot find a job is 1 minus 45%. And then also we will have 3% of employed workers that will get separated and join the unemployment group. So we get a number of 9.4 million unemployed workers for day 2. So this is the change of job finding rate we assume that happened in the economy. It stayed at 50% starting at the beginning, and then suddenly economy become bad, it's difficult to find a job, so job finding rate goes down, and then somehow it's recovered a little bit, job finding rate goes up, and then stay there forever. And then based on the dynamic calculation, we will be able to track the its impact on employment and its impact on unemployment. As you can see, if you look at the red line and compare it with the job finding rate, it is very consistent with the data observation we have earlier. In the data, when job finding rate goes down, then the unemployment rate, the red line, goes up. And when the job finding rate goes up, then the unemployment rate goes down, which is consistent with the red line of unemployment rate in our simulation.